All right, in this week's lessons, we're going to talk about some history of numbers and different ways to calculate some numbers. So we've talked about this earlier in the semester. What is a prime number? A prime number is a number that only itself and 1 can go into. Well, 1 can go into every number, so I always like to think of prime numbers as something that only itself can go into. So some prime numbers are 2, 3, 5, 7, 11, 13, ... right? And notice 2 is the only even prime. And the reason for that is because 2 can go into every other even number, which takes us to our next definition, composite. And so composite is any number that has more than 2 factors that are not prime, right? So 1 and 4 can go into, but 2 can also go into it. So 4 is a composite number. No, 1 and 0 are neither prime or composite. They don't have a name. They are just 1 and 0. So some ways to check for divisibility, to figure out what numbers can go into other numbers to see if they are prime or composite. So we just said all even numbers have a factor of 2. 4 can go into anything I got stumbled on my words. When the last 2 digits it can go into. So, like, for example, I'll write it up here because I'm going to use this number a lot. 44 can go into 44, goes in 11 times. But if I look at 144, right, look at the last 2 numbers. 4 can go into 44, so therefore 4 can go into 144. So I go to my calculator, 144 divided by 4 gives me 36. So I get 36 when I divided it by 4. If it also ends in double zeros, 4 also goes into it. 8 is similar to 4, but it goes to the last 3 digits. 9 and 3 is if the numbers add up of the composite number, they add up to something that 9 and 3 can go into, then 9 and 3 can go into that original number. So, again, using our 144, 1 plus 4 plus 4. 1 plus 4 plus 4 equals 9. 9 can go into 9, so therefore 9 can go into 144. So 144 divided by 9 equals 16. Well, 3 can also go into 9, which means 144 is also divisible by 3, which is 48. Right? If 3 and 2 can go into it, then 6 can go into it, so that means 6 can also go into 144, which is 24. And if 3 and 4 can go into it, then 12 can go into it. So 144 divided by 12 is 12. So those are some interesting ways that you can. And there's others. These are the common ones. And in some of your readings, you'll see the other ways and then in the homework. If it ends in 0, 10 can go into it. If it ends in 5 or 0, 5 can go into it. So the reason we do that is we want to go into this thing called least common multiple. And so for our least common multiple, you're doing what we call prime factorization. And I like to think of it as a tree. And you're breaking a number down into its primes. And so I can find out by this pattern, what is the first number that a set of numbers can go into? That is what a least common multiple is. So, example, find the least common multiple of 14 and 49. So I take 14 and I make it into a tree. So 14, 2, and 7 can go into it. So I like to circle them to show that they end. And they don't always end after one try. You might have to go a couple patterns, but you keep going until you end in just primes. And then we have 49, which is 7 and 7. Again, I end in my first try. And now what you do is you write your prime numbers down. So I have prime numbers of 2, and I have prime numbers of 7. Well, I only have 1, 2. So he's to the first power, which is just itself, but I still like to show it so we can see the pattern here. Then I look at 7. 7 goes into 14 once. 7 goes into 49 twice. So what I do is I take the one that has the most. So since there are 2 7s in 49, I put a squared here. And then I multiply these. 2 times 7 squared is 98. So 98 is the first number they go into. If I multiply 14 and 49 together, I will find a number that they can go into, but it won't be the first number. That's what least common multiple is. 5.2 goes into understanding the Mersenne number. And all the Mersenne numbers is a unique pattern that where you use this formula, you find another composite number. And so if you use this formula to find that number, it is called a Mersenne number. And so in Mersenne, if n is composite, then my Mersenne number will also be composite. If n is prime, then my Mersenne number will be prime. So for example, if n is 7, find the Mersenne number of M7. So what I do is I take 2 to the 7th power minus 1. Now be careful how you put this in your calculator, right? It's only, the exponent is 7, then you get that answer, you subtract it from 1. So if I go to my calculator, I do 2 to the 7th power, which gives me 128. And then I subtract the 1, which gives me 127. So the Mersenne number is 127, which is a prime number because 7 is a prime number. So I can use composite numbers and break it down into 2 distinct factors, right? And again, so if I break 35 down into my factors of 5 and 7, I can then also put it into the Mersenne formula to find a Mersenne number. And because these are prime factors, I will create prime numbers. So 2 to the 5th power minus 1 is 31, which is prime. And we already did the 7th one. The next section talks about perfect numbers. A perfect number is a natural number, or natural numbers that is perfect, sorry, if it equals to the sum. Wow, I got some typos in this one here. Not sum. Sum of its proper divisors. So, for example, a lot of different words here. If 28 is a perfect number, so factors 1, 2, 4, 7, and 14 are all factors of 28. We don't include the final number because we're looking for the perfect factors. So obviously 28 can go into itself. So we're listing all the numbers but what itself. Now if I add them up, 1 plus 2 plus 4 plus 7 plus 14, I get 28. Therefore, 28 is perfect. And so interestingly enough, if we use the Mersenne number, if we take a Mersenne number and we multiply it by 2 to the n to the minus 1, now be careful, this whole thing is an exponent, right? Then I will get a perfect number. So 13 is prime. So when I do 2 to the 13th minus 1, I get 8,191. Now notice this, again, this is an exponent. So I'm doing 2 to the 12th power, which is 4,096. When I multiply 8,191 and 4,096 together, I get a perfect number, which means if I list all the factors of this number, which I'll put some commas in so I can read it properly, 33,550,336, if I listed all of its factors, which we're not going to, but if you did, and you added all the factors together, it would equal that number, which is a perfect number. Sorry. So deficient and abundant numbers. Deficient is a natural number where the number is greater than its proper divisors. And an abundant is a natural number when its numbers is less than its proper divisors. So for example, 26, I list out its factors again, 1, 2, and 13. 1 plus 2 plus 13 is 16. 16 is less than 26, so this is considered a deficient number. 24, list its factors, 1, 2, 3, 4, 6, 8, and 12. I add all of those together, I get 36. 36 is bigger than 24, so that is considered an abundant number. So this week we'll play around with different types of numbers. Please reach out if you have any questions. Let me know if there's any issues or concerns with the video, and I hope everybody has a wonderful week.